How does quantization error affect ADC? Imagine trying to capture the sound of a whisper with a camera that only takes snapshots every few seconds. You might miss some details or get a blurry picture. That's similar to what happens in an analog to digital converter when quantization error occurs. When you convert a continuous analog signal into a digital form, the process involves dividing the voltage range into a set number of levels based on the resolution, or bit depth, of the ADC. Because of this, the actual input voltage is rounded to the nearest available level, which introduces an error called quantization error. This error is the difference between the real analog voltage and the digital value that the ADC outputs. Think of it as a tiny gap or mismatch between the true signal and its digital representation. The more levels the ADC has, the smaller this gap becomes, but it can never be completely eliminated. This inherent error limits how precisely the ADC can representing the original signal. It's like trying to draw a smooth curve with only a few straight lines. You can get close but never perfect. Quantization error also acts like a kind of noise added to the signal, known as quantization noise. This noise raises the noise floor, which is the background level of unwanted signals, making it harder to distinguish small signals from the noise. When the signal is weak or the ADC resolution is low, this noise becomes more noticeable and can degrade the quality of the digital output. The signal-to-noise ratio, which compares the strength of the signal to the background noise, is affected by quantization error. Higher resolution ADCs, with more bits, have a better signal-to-noise ratio because they can representing the input more accurately. For example, an ADC with 10 bits can distinguish 1024 levels, while a 16-bit ADC can distinguish over 65,000 levels, greatly reducing quantization error. But it's not just about noise. Quantization error can also cause distortion in the output signal. When the error isn't evenly spread or correlates with the input waveform, it can create harmonic distortions, especially in audio or precision measurement applications. Engineers need to consider this when designing systems. Techniques like increasing the resolution, oversampling, or adding small amounts of noise called dither can help minimize the effects of quantization error. In digital electronics and embedded systems, understanding how quantization error impacts the accuracy and quality of the digitized signal is essential. It influences decisions about which ADC to use, how to process signals, and how to ensure the system performs reliably. So, in simple terms, quantization error is a natural part of converting analog signals to digital, and managing it is key to getting the best possible results in electronics and embedded systems.